In yesterday's video, I spoke about 7 formats of a case interview, and among them is the quantitative assessment. Now, for quantitative assessments, what the interviewer is measuring for is how quickly you can solve math problems. So, for example, large numbers, multiplication, division, or how you can interpret data. So, you might be given like a chart or given some sort of infographic, and your task will be to determine what is the most important data that is being presented to you and how can you use that data to either solve a problem or do some sort of analysis. So it's the way to pass quantitative assessments. For example, the McKinsey PST. Let me find what the PST means. Problem solving test. So there's the McKinsey problem solving test. And the way to pass this is usually through practice. So practice is one of the key ways to get faster, get more efficient in solving math. Remember that you'll be on a clock, so there'll be a time factor to this assessment. So the more practice you get in to do this math and numerical reasoning, the better for you. Today I want to talk about estimation. And why I particularly like estimation is that in day-to-day client engagement, there is usually some sort of estimation that needs to be done. You sometimes just need to, you don't know the correct answer or you don't know the actual figures for a client's question. And so you just have to give your best estimate. In fact, there's also a term guesstimate, and we'll talk about that in a bit. But today, Victor is teaching us about some of the important ways we can perform estimates on the fly and how to be reasonable, or will I say a little bit more structured about it. So it's not about just guessing any number and assuming that the client understands that you don't know the exact number of gallons of gasoline that is pumped every day in the USA, for example. But in as much as you're not asked for a precise answer or a precise figure, you are also expected to give a reasonable estimate that will be sort of a ballpark. So, reading through Victor's notes, he gives an example of when estimation really helped to pretty much solve or answer a question that the client had been asking for about 3 years, if I remember correctly. And here they were trying to understand if they should pursue a new business opportunity. And what he did was to get a best case scenario estimate of how much in millions of dollars in revenue they could make from that new opportunity. And it turned out that what had been a 3 year debate ended in just 10 minutes because he was able to show that using the best case scenario estimate, there will not be enough revenue to justify the investment that was going to go into that business venture. So this is just a good context or sort of example, analogy to show that sometimes estimates can prove to be very valuable for business. So there are a few skills, actually about 6 of them, that you should keep in mind when doing estimates. The first one is that you sometimes need to do precise arithmetic with large numbers. And here we have an example of a market of 2 million buyers with a market share of 15% and revenue per buyer of $300. And the key here in making this calculation is being able to arrange this problem in such a way that you can do the easier computations first. So he gives an example of that instead of trying to figure out what is 2 million times 15 and then times 300, you could rearrange that into 2 million times 300. That is easier to compute, so you get 600 million. And then you find 15% of 600 million. Again, instead of trying to calculate what 15% of 600 million is, depending on your math skills, that might be easier or harder for you. You can also think of it as 600 million times 10% plus 600 million times 5%. And it's easy to see that 600 million times 5% is simply half of 600 million times 10%. So once you can get this number, which will be 60 million, then you just half that, 30 million, and you get your answer, which will be 90 million. The point Victor is trying to make here is that while it might look like, oh, there's so many steps to go through to just calculate this, especially when you're under a time crunch, it's better to be able to, first of all, rearrange the problem in such a way that it's easiest for you to solve, and then follow some sort of structure or structure that comes from prior practice or preparation to break down that problem and make sure you're not making a mistake. Because again, the key to this type of problems is that you need to get a precise number. So here, your accuracy is going to be tested. The second skill is ability to round numbers intelligently. And here, the key point is that for this type of assessment, you are expected to provide some sort of directional answer, not necessarily an exact answer. And let's look at an example. So if you were to calculate 54 million times 17.5% times $300, quite similar to the last problem, but now we have some numbers that are not the easiest to work with. And so how do you approach this problem? The first is to figure out, okay, if I were to round up 54 million, where do I round it? Should I round it up or round it down? Now, it's closer to 50 million than it is to 60 million. So you could round it down to 50 million. But one thing to keep in mind when you round down to 50 million is that it's very likely that your estimate is going to be lower. So if you round it down to 50 million times 17.5 times 300, you can immediately do the calculation of 50 million times 300, or better still, round up again 17.5%, so it's easier to work with. Now, when you're trying to round up or down 17.5%, you keep in mind that you previously rounded down the 50 million from 54 million to 50 million, and so it will probably be a better idea to round up to 20% than to 15%, both of which are about 2.5% away from the exact number that we have. And therefore, 20% will be much easier to work with, so you can round this 17.5% up to 20. This gives us 50 million times 20% times $300. This is a lot easier to work with. I should also note that Victor gives some sort of, gestures that help to stay on track. So initially, when he rounded down from 54 million to 50, he points downwards. So he has some sort of physical indication of what his estimates to look like. And when he rounds up from 17.5% back to 20%, then he kind of puts his hand in a neutral position, thereby helping him see that now he's going to be around the ballpark of what his actual figure was to be. So 50 million times 20% times $300 is a lot easier to calculate, because now you can just do 20% of 50 million, which would be 10 million, and then multiply that by $300. This will give $3 billion. Now, if you calculate what the actual value was to be, the actual value was going to be $2.835 billion. But then we've rounded up and we now have $3 billion, which is pretty close to the actual figure. And this is well within the 20% margin of error that most consultants use. So to recap, when you're trying to round numbers intelligently, it's usually better to round to a whole figure, usually figures that have a zero with them, like tens or hundreds, and also to keep track of whether your estimate is going to be too low or too high, depending on how you've rounded the numbers. The third skill Victor is teaching is finding a proxy. Finding a proxy essentially means being able to find something that is similar to what you're calculating, but is easier to work with. Uh, of course, the meaning of proxy is a substitute for something else. So let's take this example of how many gallons or liters of gasoline does a typical filling station pump each week. It's pretty difficult to know in precise numbers how many gallons are being pumped each week. And for this, you can think of a proxy, which could be how many pumps are there in a typical station. So, for example, the average number of pumps each station has on site. Or another proxy could be the average number of cars that drive by based on the time of day. You could also think of a proxy as the average percentage of pumps being used in a typical station, etc. The idea here is to find something that might be more, it's easier to determine. For example, the number of pumps in the station. You probably have been to a filling station quite a number of times, and you can estimate what the average number of pumps will be, and use that proxy to calculate the estimate that you've been asked to make. As another example, he shares this actual case interview question that he was asked. So assume the year is 1980 and Motorola just invented a new technology called the cellular phone. The first 3 years of revenues for this technology have been terrible. As manufacturing costs and prices decline, what will sales for cellular phones be in 1985? And he shares the story of how he walked through this problem. The key insights here was that he was able to, based on an idea that popped in his mind, determine how did other new technologies perform in the first 3 years after they were launched, and use that to sort of act as a proxy for what you expect cell phones to do. So, to summarize, this method of estimation is you, instead of focusing on the details of what exactly you've been asked in the case interview, to try to get a proxy, a substitute that can give you a reasonable estimate of what your number should be if you had gone through the exact question you've been asked. The fourth skill is to identify how your proxy is imperfect. Now, of course, for example, the number of gallons pumped every weekday in the US, it's very easy to see how sometimes the imperfection can come from the number of pumps that are available in a station. So if, for example, a station had only 6 pumps, no matter what estimate you're given, that number of pumps, 6 pumps, is the upper limit. So you cannot pump more gallons than 6 pumps could possibly pump in a day. So one of the limits would be, to that proxy, would be how many pumps are there in the station. So as you can see, he says, we know, however, that a gas pump will not be used all day long. So while the number of pumps is a useful proxy, it's also imperfect because one, depending on how many pumps there are in the filling station, there is also the likelihood that those pumps are not used 24 hours of the day. So there will be closing times when the station is not functional, for example. Or if it's a station that functions 24 hours a day, then at least the station cannot pump more than the 6 station. The station cannot pump more than the 6 pumps that it has. So to make this a little bit simpler, it is useful to, while making your estimate and getting your proxy, also identify what are the limiting factors for that proxy, so you don't just balloon your estimate and give a very large, unreasonable number. The fifth skill is being able to segment your estimates to minimize your proxy imperfections. And the way I understand this is that it's it's important to sometimes break down your estimations in such a way that you can sub-estimate for each of the breakdowns that you've made. So that's a lot of words. Let me simplify that. For example, you have determined that in a station there is perhaps 8 pumps in that station. Or actually, let's follow his structure here. So first, he creates 3 different estimates: one for peak driving hours, another for off-peak hours, and another for when the filling station is closed. And so you have a formula: weekday gallons pumped is peak hours plus off-peak plus closed hours. Now, like I was saying just now, being able to sub-estimate each of those breakdowns that you've made, which is also called guesstimating. So you first take the peak hours of gallons pumped. How many peak hours are there in a day? Usually peak hours, for example, in the US is between 7 and 9 a.m. and 4 to 6 p.m. So you can break that down into the number of peak hours and then estimate how many gallons are pumped per peak hour. And again, there's another formula for that, which would be the total number of pumps, which would be the upper limit, the percentage of utilization of those pumps, the number of cars filled per hour, and the number of gallons per car. So being able to break this down in such a way that you can then make reasonable estimates for each of these sub pieces and then sum everything up in the end. So we start by calculating how many pumps there are in the station. So let's say there are 2 islands in a station, and each of those islands has 2 stations, and each of those stations has 2 pumps. Now, just for good measure, I know I had to sort of understand what a gas station island is. So let me show you what that could be. So a gas station island would be something like this. So here's the island for the gas station. And as you can see, it has, let me close this one. It has 2 pumps in the island and also 2 stations around it and 2 pumps per station. So 2 pumps on the left side and also on the right side. So that gives us 8 pumps per station. And if you assume that a pump is used 80% of the time during the peak hours, let's say between 7 and 9 a.m. or 4 and 6 p.m., the pumps are used up to 80% of the time. And then you calculate how long it takes to fill a car. So it takes a minute to park the car. It takes about 4 to 5 minutes to pump the gasoline, and then 1 minute to grab the receipt. So in a 60-minute period, at 6 minutes per car, you can fill 10 cars per hour. So now we have 8 pumps, 80% utilization, 10 cars per hour, and then we need to figure out how many gallons per car. And he says his mid-sized car takes about 12 gallons when it's completely empty. However, there are some smaller cars, and also there are people who don't refill when their gas is empty. So we can also take an estimate of 10 gallons per car, which gives us in total about 640 gallons pumped per peak hour. Now, if we put that into our peak hour formula, we know that there are 4 hours that are peak, 7 to 9 and 4 to 6. So we have 4 times 640, which gives a total of 2,400 gallons. Now we do the same calculation or similar calculation for the off-peak hours. So for off-peak hours, we can go through similar process, but interestingly, consultants are lazy in a way that is efficient. So what he does is just to calculate how many off-peak hours are there in a day, which is all the hours minus 7 to 9 and 4 to 6, which is 14 hours. And then he estimates how many cars are being filled during an off-peak hour. So he says during off hours, I'm often the only person at an island, or sometimes one other person is there. So the guess is about a utilization rate of 25 to 50%. Therefore, we can simply divide what we've had per peak hour. So per peak hour, we have 600 gallons. And if we divide it for off-peak hours, you have 300 gallons. Now, if we have 14 off-peak hours in the day by 300 gallons, we work that out to give 4,500 gallons. Now, because we know that when the pump station is closed, there can be no gallons pumped, in total, on a weekday, we have 6,900 gallons of fuel pumped. And that's a way to sort of answer this arbitrary question that initially could be quite fretting or could cause you to panic on how am I supposed to know how many gallons are pumped on a weekday in the US. But you see that going through such a structured approach can help to make a reasonable estimate of how this number can be reached. And one thing to remember is that in a case interview, while there are times when you need to provide a precise answer, many of the times the interviewer is looking at what is your thought process in solving this problem. And that will be the kicker. That will be more important for the interview and for the success or failure of that interview in how you have thought through the process versus getting a precise answer. So that's video 2 for our case interview secrets. We'll come tomorrow and talk about more types of case interviews and how to ace them.